Okay, so we have this distance equals rate times time word problem to deal with. So that's the first thing we need to know, distance equals rate times time. And typically with these, you have two different situations going on. And with those two separate situations, you're either going to set them equal to each other, or you're going to add them together. Sometimes you could even subtract them. So we're going to try to set up our two situations and then figure out what do I need to do with them. Okay, so all the information we have is we have Marisol, and she left Los Angeles at 2:30 to drive to Santa Barbara, a distance of 95 miles. Now, that's the whole trip, is 95 miles. Okay, and then we know more. The traffic was heavy until 3:20. Okay, so from 2:30 to 3:20, the traffic was heavy. Okay, and she drove, so I'm just going to call that heavy. All right, she drove the rest of the way in very light traffic and arrived at 4:20. Okay, so from 3:20 to 4:20, we're going to call that our light situation. Okay, now her speed in heavy traffic was 40 miles per hour slower than her speed in light traffic. So let's let R be the speed in light traffic. We don't know what it is. We got to call it something. So I'm going to call it R, which stands for rate in our formula. But now in heavy traffic, she was 40 miles per hour slower. So I have to call this one R minus 40. Now, honestly, that is the key to the problem. So I want to make sure you understand that. In light traffic, we didn't know how fast she was going, so I just called it R. But we do know that in heavy traffic, it was 40 miles per hour slower than R. So say she was going 80 in light traffic, which is way too fast, then she would be going 40 in heavy traffic. Or say she was going 60 in light traffic, then she would only be going 20 in heavy traffic. So whatever she's going, I'm going to subtract 40. Okay, now we know that the total distance back over here is 95 miles. So if we set up a formula right here, so distance equals rate times time for this situation, and distance equals rate times time for this situation. Okay, well, we know our rate is R minus 40. Okay, how long did she do R minus 40? Well, that was from 2:30 to 3:20. Now, that's not a whole hour, right? It's like 50 minutes. Now, our time needs to be in hours because this is in, our rate is in miles per hour. If you can notice in here, it's got to say it somewhere, was 40 miles per hour. That's terribly important, that our rate needs to be in miles per hour. So this is in miles per hour, which means our time needs to be in hours. Minutes is just not going to cut it. So we're talking 50 minutes right here, okay? But that's out of 60 minutes, which is an hour. So basically, if I reduce this fraction, my time is 5/6 of an hour. I could see where that'd be a booger in the problem also. Okay, now for our second scenario, our light traffic situation, I still have rate. Well, my rate, we just called it R. My time, how long did she do that? Notice it was for 1 full hour. So it's 60 minutes, but how much of that is an hour? Well, 60 out of 60, it's 1 hour. Okay, so this one is 1 hour. Now that's D for each of them. This is D for heavy traffic. This is D, or distance, for light traffic. Now we know that the total D for both heavy plus light, so if I add heavy plus light, that's going to equal 95 miles, right? So this is my distance in heavy traffic, which is going to be 5/6, I'm going to put that in front, times R minus 40. All right? Plus light traffic, which is 1R. So I'm just going to put plus R because I went ahead and multiplied the 1 times R equals 95. So basically, this is the equation that we have to solve. Now what I'm going to do is going to put this on another page so we can work hard on just this equation. Okay, so you'll notice I just transferred that same equation. Remember, this was heavy traffic, this was time, and this was rate in heavy traffic. This was light traffic. The time was 1 hour and the rate was just r. Notice we don't actually know any rates at all, but we know this is equal to d for heavy. This is equal to d for light. If I add my heavy d plus my light d, that's my total distance. Now I just need to solve this equation. Now, what I would like to do is eliminate this 6 right here. I know you've heard the term clearing fractions, or maybe you have, but I've discussed it in the video. To clear fractions, you look at all your denominators, I only have one, and you multiply every term by that denominator. So I multiply by 6 right here. Now that's considered one term because it's all multiplication. I'm going to multiply 6 right here and 6 right here. Okay, now why did I do that? So this 6 cancels with that one, and that leaves me with 5 times r minus 40. Plus, now nothing cancels here, that's just 6r is equal to, and in my calculator I'm going to type 6 times 95, and I've got 570. Now I just need to solve this equation. Distribute the 5 inside, so I have 5r minus 200 plus 6r is equal to 570. I'm going to add my like terms, so those are my r's. 5r plus 6r is 11r minus 200 is equal to 570. I'm going to add 200 to both sides of this equation, and that gives me 11r on the left, and then 570 plus 200 is 770. I'm going to divide both sides by 11 to get r is equal to, so 770 divided by 11 is 70, right? I had a brain freak out there just a minute. So yeah, 770 divided by 11 is definitely 70. Now, what did we just find out? Let's go back and look at our problem. We got that r was 70, okay, with all the scribble. So that's this dude over here. This r is 70. And remember, that was light traffic. So what's her name? Marisol was going 70 miles per hour in light traffic. Well, how fast was she going in heavy traffic? Well, it's 70 minus 40, right? So in light traffic, she was going 70 miles per hour. And then in heavy traffic, she was going 70 minus 40. I know you're way ahead of me there, is 30 miles per hour. Now, you always want to answer the question. I have to make myself go back and read these problems to make sure I really put in what Newton Alta wanted me to. It asks, it says, find her speed in heavy traffic. So the heavy traffic was the 30 miles per hour. And so hopefully when you're working on this problem, the 30 miles per hour is correct. I haven't even pulled up to see what the right answer is. But I hope that helps. This was my speed version of this problem. But I do understand the stress that a problem like this induces. So hang tight. It's going to be okay.